All right, welcome, gentlemen. Just welcome in. I'm just kind of taking attendance as I let you all in. So just kind of bear with me. I hope everyone had a good weekend. Hopefully you were able to work on the exam. I think it was due. Let me see the time. Right now. Not this thing is technology's being technology, and it's uber slow. Let's go like this. All right, I know I've got these guys. J. Okay. Welcome everybody. Welcome, welcome. You got a packed house. Just bear with me. He either. I'm not gonna worry about it. Let me see who's here. Doo-doo-ba-doo-ba-doo. He must have like popped in and out. That happens. T. Doo-doo-doo-doo-doo. Almost there. And then I think that's the last one. Come on. Where are you? Right there. Cool. Okay. I think I can let both of these guys in. Okay, so we're going to go ahead and get started. So welcome. I'm glad that you guys are here. Hope everyone. Does anybody care to share like their experience so far, either about their weekend or anything? Anybody like just want to share anything with the group? Like how was your weekend, or how are you finding, like how is this working out for you? Is it working for you? Is it not? Like would you like to see some changes? Um, Go ahead. Mm. What awesome. You said initially what was it that confused you? Hmm. You talking about the my math lab? I get it. Mm, okay, but you were able to like catch it and fix it. Okay, is that the lab portion, or are you talking about the homework? Oh, okay, okay, okay. Yeah, yeah, yeah. The lab. Yeah, that's. I mean, it is a little bit. It is a little bit. A little confusing. And I just put the. I think that what Dr. Lamar is doing. I like what she's doing. Like I've tried to do the lab, and I just didn't have that resource or that creativity. And then when I kind of sat and thought about what she's doing, I was like, oh, I see it. I see the value in it. Um, so that's why I like what she's doing, and I was like, yeah, just keep doing that because it's a great compliment to what we're doing. Like we're kind of talking about the stuff we need to talk about, and then she kind of that program with Alex and all of that. Give me just a moment. Oh yeah, he was here already. Um, Alex, I like the concept where it customizes it for each student. And it is a little bit confusing initially, but and like that's why I kind of lax about certain things as far as just as long as you put a genuine effort and I feel like you're being genuine to some degree, and I don't get this like this eerie feeling of whatever, then But I mean, but yeah. Anybody else want to share like their experience? Like, thank you for sharing, by the way. Share like either. Go ahead. Hmm. Hmm. So yeah. So as a general blanket statement, if I don't respond to your email, you have to do exactly what you're doing and just ask me in the next class because I miss them very easily. So that's why, and the way we have it set up, we can use class time for this kind of stuff. Like we have a whole lot of extra time kind of built into our structure. So that's why, I use class time for like this kind of thing. This is the time when I know everybody's free, and we have the time to kind of sit and talk about this kind of stuff. Yeah, it should be basically on Pearson. There's like a homework assignment for each week and a quiz each week. The quizzes are really short. They are like 5 questions, and I know I kind of but I went on and loaded all the quizzes for the semester, all the homework and quizzes for the semester. The only thing that's not preloaded are the exams. We did have exam one that was due like 6 minutes ago. With any assignment that we have on Pearson, we do get unlimited attempts. There are deadlines for each assignment, but honestly, you can work on all assignments past the deadline with only a 10% late penalty, right? So like if you really, really want like an A minus, if you submit something late, you can still get it all the way up until like the very end of the semester. So I kind of like by default just went on and built in like a extension into all the assignments because in the past I got tired of having to manually go through for each request and like grant extensions. So I just made a decision to just go ahead and factor in an automatic extension on all the assignments. So if you want something higher than a 90, then you just got to submit it a little bit earlier. And I know for those quizzes that, I posted them, loaded them in like week 3. I gave you like a couple of weeks to work on those. But again, and the quizzes, another thing I want to mention is like, don't stress too much about like the homework and quizzes. Do the best you can with those. But if you don't do anything else, just make sure your exams are in order. The exams are going to be the bulk of your grade. I don't want you to be stressing out about homework and quizzes where the homework is only 10% of your overall grade, maybe more like 9, and the quizzes are like 9 to 10% of your grade. Um, I don't want you to stress too much about it. Just do the best you can with that. Again, I want you to put more of your energy into performing on the exams and just do the best you can with the homework and just attend the lab. The homework is really there to just kind of give you practice and get you prepared for exams and like any kind of questioning. You pretty much learn in the homework and then you showcase what you've learned when you take the exams and stuff. And like so like we mentioned, so exam one it was due like a few minutes ago, and you can still work on it. You can improve your score. The system is set to take your highest score. You get unlimited attempts. So and then like for exam two, I do need to go ahead and sit down. I want to schedule like make some blocks and like so people can choose time slots. And I want to just give people an opportunity like to do a oral component to exam two. I'll probably still have like the Pearson part, and I'm thinking like maybe 20% of your grade is going to come from an oral exam, just like about 15 minutes. We got a lot of students. I'll do the best I can. It's going to take me some time, but we're gonna see how that goes. I want to incorporate something like that. Um, before I need to go back and check my YouTube videos because I'm not sure if like when you guys speak if it picks it up or not. I think this is all good though. I can't think of anything else. Any other questions before I kind of move on with the next section that I'd like to talk about? Oh, there's something in the chat. Let me check the chat real quick. I think it was like this. The tutor. I would say contact the math office. Like if you had to go to the Morehouse website and call the math office, and they'll connect with the secretary, and she has the information on the tutors. I'm sure it's in my email somewhere. Last time I checked, I know they were still setting them up, but the most updated information, just contact the math office and say, hey, how do I connect with the tutors? And they'll tell you the status on that. That's a good question because I know, like my students in college algebra, we all need it. Like, and it's crucial. So, and they're actively working to get that set up if it's not already set up. But yeah, I would just contact the math office. Okay. So let's see, the last full lecture that I remember doing. Now, this might not be what I've done with you all, but I've done it. So, today I wanted to go through section 1.6. I kind of want to check one other thing. I'll check it later though, since I'm streaming right now. But yeah, today I wanted to go through section 1.6, and just feel free to either type in the chat or unmute yourself if you have questions. I think this past exam you were only responsible for sections 1.1, 1.2, and 1.3. I've definitely done section 1.4 and 1.5, so that's recorded. You just have to go and watch that, take notes, and come to this time period with questions. And so this section 1.6 is going to be the last part that you need for exam 2. If you're not ready, like if what I'm discussing now, just kind of be present and just kind of chime in. But this is still a good time to kind of be practicing and working on some assignments. So like if I'm ahead of where you are, then just kind of just be present, take notes as best you can, because this is being streamed. I don't really want you to go back right now and listen to 1.4 because I don't want you to be too distracted. But you can be working on like something, and like feel free to, you can always stop me, like just stop me, and like you can ask questions about anything that you're working on. Yeah. Okay, I'm gonna suppress my audio just so I can focus, and then let's kind of get the party started. Hopefully this thing isn't lagging. It seems like it's okay. Let me check one thing. Let's see. Do I need to put that back? Yeah, let me put that back. So I had it about here. Okay, that looks good though. So I hope I get the impression that most people are doing well. Seems like everyone had a good weekend. My weekends are just like, ugh, I don't know. They're weird. Anyway, so we're moving into section 1.6, combining functions and composite functions. Some objectives here. We want to define basic operations on functions. We want to form composite functions. Find the domain of a composite function. We want to decompose a function and apply composition to practical problems. Okay. So we have some concepts to introduce. We have the sum, difference, product, and quotient of functions. So you know how like in algebra or in arithmetic, you can add, subtract, multiply, and divide numbers? Well, we have a way of doing something similar with functions. We can add, subtract, multiply, and divide functions. So let f and g be two functions. The sum, f plus g, the difference, f minus g, the product, f times g. Let me highlight some of this stuff. The product, f times g, and the quotient, f divided by g, are functions whose domain consists of those values of x that are common to the domains of f and g, except for f divided by g, where all values of x make the denominator 0. These functions are defined as follows. I'm going to come back and revisit this idea of domain. When we talked about functions in the previous sections, domain is basically your set of input values. So then when we start combining functions in this sense, your domain is going to be the input values that are common to f and g. The only restriction is when we have that quotient function, f divided by g, remember, we cannot divide by 0. So that's why we have this part here that says we have to exclude any x that makes g of x equal to 0 because we cannot divide by 0, right? That's kind of a mouthful. Let's work some examples, and I feel like that'll become more clear as we kind of get some reps in. Now remember, what you practice is what you'll get. Whatever you practice, you'll get really, really good at, right? So, just ask yourself, what are you practicing? Because I'm really good at practicing like complaining. I'm really good at complaining, but it doesn't fix anything. I do realize that complaining like brings things to my attention, but it's not until I like calm down and like take action does anything change. So complaining serves its purpose, but use it to be constructive. So anyway, what do you practice? So anyway, whatever you practice, you'll get really, really good at. So what we're talking about here is like some of the notation, like how it's going to appear or how you're going to see it. For instance, if you see this f plus g of x, right? So this is function notation. A lot of times when students see this, they try to multiply by x. We're not multiplying by x there. That's a common mistake that students like to make. I know it kind of looks like we're distributing the x, but that's not what's going on. All right, so be wary about multiplying x. That's not what we're doing. What this means, when you see this f plus g of x, all this means is f of x plus g of x. Just add the two functions together. So just don't try to introduce another x there. Similar here, right? If you see f minus g of x, that just means subtract the two functions, f minus g. Again, product is the same thing, just multiply the two functions, and quotient, divide the two functions. Again, we cannot divide by 0. We cannot divide by 0. Okay. All right. So this is just a random thing. I don't know if any of you guys study astrology or anything like that. This is just random. I have this app called the Pattern app, and so I just got a notification. It's like, just check it out. It's kind of creepy how, like, you put in your birthday stuff, and it's always saying stuff that I'd be thinking about. I was like, oh my god, this is so creepy. It's just fun and interesting. But yeah, it's called the Pattern app. Just check it out. Shameless plug, marketing for somebody else, but it's very interesting. I don't know how they do it. Anyway, so let's consider this. We have f of x is this and g of x is this. Find the following functions, right? Okay, do I need some space? Yeah, let me give myself some space. So I'm going to introduce another page here, and let me get a copy of this. Give me just a moment. I can delete that one. Yeah, this is what I need. All right, cool. Okay, so we're going to take that and we're going to drop it right here. Boom, boom. Come on. Make us some space for ourselves. Add a page. The view, we're going to go seamless. And I need some lines. Do I need lines? Yeah, let's write on some graph paper. Okay. And let's make this change. So given this f and this g, we're asked to find each of the following. So let's start with part A, right? So, and let me give myself a little bit more space. So then our f of x is x squared minus 6x plus 8, and our g of x is x minus 2, right? So then part A asks us to do f minus g of 4, right? So again, we're not multiplying by 4. What this means f of 4 minus g of 4, right? This means f of 4 minus g of 4, right? So because we're just evaluating this combination of functions at a number, at a x value of 4, we can just evaluate f of 4 by itself, g of 4 by itself, and then subtract our answers, right? So if we do f of 4, that's going to be x squared minus 6x plus 8, all right? So what I did here, I replaced each x with a blank set of parentheses, and what goes into the blank parentheses, what are we substituting? We're substituting foul. So now if we evaluate the number, that's going to be what? 16 minus 24 plus 8. What is that? 4 and 4, negative 8. Is that 0? That looks like 0. Okay. Hopefully I'm not making any mistakes. Let's go to g. So we also want to do g of 4. So that's going to be x minus 2. The x in this case is 4. That result is 2. So then when we do f minus g of 4, f minus g of 4, this means f of 4 minus g of 4, and so that's going to be, it should be 0 minus 2, which is negative 2. Okay. If anything is not clear, just stop me, or feel free to type in the chat. Let me go like this. Let me check the chat. Ooh, my temperature here. Like, I don't understand. I guess because I be sitting like directly in the sun when I'm doing these presentations. I be sweating like I'm working out. I'm like, man. Anyway, part B, we got f divided by g of 3, right? So this one's similar. F divided by g of 3. Okay, let me get a copy of these guys. From here, let's copy. I'm going to paste them because these are the functions that we're using, just so I can have, it can be convenient access. Okay. Okay. So again, what does this mean? This means f of 3 divided by g of 3. All right. F of 3. So all this means is f of 3 divided by g of 3. Let me do this. Okay. So in the same fashion, we can just go ahead and do f of 3 and I'm just going to write a little bit faster here. X squared minus 6x plus 8. X is 3 in this case. 9 minus 18 plus 8. Is that 0 as well? Negative, no, it's not. Negative 9, negative 1, right? Negative 1. I'm just being a little bit OCD. I really wanted it to be on one line, so I'm just shrink it down a little bit and get it on one line and then put it back. Just because I can. Boom. Okay, that's fine. So we did f of 3. Let's go ahead and do g of 3. G of 3, that's going to be x minus 2, but the x in this case is 3. That's 3 minus 2 is 1. So then f of 3 divided by g of 3 is going to be, should be negative 1 divided by 1, which is ultimately negative 1. Okay. Hopefully this is okay for everybody. Okay. Let me see the time. Man, these sections, it's like it don't really be that much, but for some reason it just takes so long. I'm like, yo. Part C is f plus g of x. Okay, so now we're not evaluating anymore. Okay. So then part C asks us to do f plus g of x, right? Again, what does this mean? This means f of x plus g of x, all right? I'm going to use what's at the top of the screen. So then that's going to be f of x, which is x squared minus 6x plus 8, plus g of x, which is x minus 2. We don't need to distribute any negatives, so we're okay here. We should combine like terms. So I think the x squared is by itself. Negative 6x plus x is a negative 5x. 8 minus 2 is 6. So then I'm going to go with this result. Okay. Let me check the chat. The chat looks okay. I don't see any notifications. I'm going to keep moving. So that was part C. Part D, f minus x. Okay, so then it's minus times and divide. Okay. So part D is f minus g of x. Again, this means f of x minus g of x, right? So then that's going to be, okay, we got this x squared minus 6x plus 8. Now, if we're saying minus g of x, all of g of x needs to be in parentheses. I mean, honestly, we should put f of x in parentheses as well, but because of like the associative property of addition, we didn't really need it on the first part, but the second part we definitely need it for the following reason. G of x is what? X minus 2, right? So if we're subtracting g of x, we need to be able to distribute that negative, right? That negative is applied to each term in g of x. If I were doing bonuses, I don't even know why I said that. I'm not doing bonuses. It's just too much. I can't do that right now. It's too much. But I would be curious, like, if anybody would know the difference between what's the difference between a term and a factor. Like, because with this I said, we want to distribute the negative into each term. What's the difference between a term and a factor, right? Terms in this context, let me see the chat real quick. Terms in this context are things that we add and subtract. Factors are things that we multiply and divide. I think that's how that goes, yeah. So like terms are added, and you can generally rewrite subtraction as addition, so that's why I'm kind of like a little bit wavering. And then you can also rewrite division as multiplication, generally speaking, right? So terms are things that we add and subtract. Factors are things that we multiply and divide. Okay. So we want to distribute this negative into each term, okay, into part G. So when we do this, the following happens. The first part, we can just lose the parentheses because there's nothing to distribute. So we have x squared minus 6x plus 8. I just brought that down. When we distribute the negative, we get negative x plus 2. Then when we combine like terms, we'll go ahead and add another page. Man, Man, I'm not even close to the end. It's eating into my time. Someone said save this for a little bit later, but that's okay. When we combine like terms, that's if I just want to do it in one take, which I do. So I'm probably just going to keep going. If we combine like terms, we'll get x squared. Negative 6x minus x is a negative 7x. 8 plus 2 is 10. And I think that's it for that one. Okay. I think we got two more. Let's go ahead and do multiplication. So A, B, C, D, E. It should be f times g of x. And this just means f of x times g of x. Okay. So then f of x is this guy. We got this x squared minus 6x plus 8 times g of x, which is x minus 2. Right? So we need to FOIL. Every term for one part needs to be multiplied with every term of the next. So like for instance, the first term in f is the x squared. So I'm going to say x squared times x and x squared times the 2. Every term in the first one needs to be multiplied with every term in the second. If this was like a binomial times a binomial, you might recognize this as FOIL. FOIL is first, outer, inner, last, right? Okay, let's keep it moving. So first I'm going to do trying to think of how I want to write it. I want to say this x, I want to say x squared times x and x squared times the 2, right? So then we'll get x cubed minus 2x squared. You know, and then I just want to keep going because then the next one is the negative 6x times x and then negative 6x times the 2, right? So then I'm going to get negative 6x squared. 6 times 2 is positive 12x, right? And then lastly, I want to say the 8 times the x and the 8 times the 2, right? So that gives us 8x. 8 times 2, this is going to be a negative 16. So because of the way I FOILed it, my like terms were side by side. That's why I was hesitating. I was like, okay, I know there's a way I can do this where when I'm done, my like terms are side by side. And so that's why I did it that way. Okay, so we got fortunate. Our like terms are side by side. So then if we combine like terms, we get x cubed. What is that? Negative 8x squared plus 20x minus 16. And we're just going to leave it there. Okay. Style. Okay. A, B, C, D, E, and then I think it's one more F. F divided by G of X. Again, this means F of X divided by G of X. Okay. So then this is going to be, what's your F of X? I think it's just x squared minus 6x plus 8 divided by G of X, which is x minus 2. Let's see if we can get something to cancel. Like let's try to factor the top, right? Can we factor the top? So we got a trinomial, we got x and x, okay? This second plus, the second sign tells us we know the two signs are the same, right? They're either both positive or both negative, we just know they're the same. This first sign tells us that the larger number is negative. So this tells us, so now we know both the signs, it has to be minus and minus, all right? It has to be a minus and a minus. So now we're looking for two numbers that multiply to give us 8 and add to give us 6. I think it's what, 4 and 2? Notice that negative 4 times negative 2 is a positive 8. Negative 4 plus negative 2 is negative 6. So now you should see something happening. This should cancel this. It should be, the result should be x minus 4. And we should make a statement that x cannot be equal to 2, right? because 2 would make a 0, would create a 0 in the denominator. But I mean, I guess we didn't really need that since the solution is just, well, actually, yeah. Let's go with this. I'm going to go with this. We need to be clear that, x cannot be 2 because it makes the original function undefined. All right, I'm going to go with that. Okay, so I think that was that. So let's compare what we got. Let me go back to view, single page. I think I'm going to go ahead and turn off my graph paper as well. Okay, so the first one we got, part A, looks like we got -2, and then the second one was -1. Let's see. You see the -2, you see the -1. X squared minus 5. I feel like we got all of this. I'm just going to kind of let it be. I think we got that stuff as well. And you see the x minus 4, and x is not equal to 2, right? So the chat looks okay. We only have like about a little over 10 minutes remaining in class, just a little bit over 10 minutes. So let's just kind of keep going. I don't know if you heard my voice crack just then. I heard it, and I'm like laughing so hard on the inside. As professors, like, it's so funny, like when we be like in front of the students, like just random stuff be happening. And I'll be like, usually I try to like keep talking and I try to play it off, but I'll be thinking to myself, did anybody notice that? Do they hear this stuff? Like, do they know what's going on? Like, I just be having all these conversations in my mind. I just don't be saying nothing a lot of times. It'd be so funny though to me. Anyway, okay, so composite functions, right? Composition of functions. Let's see. If f and g are two functions, the composition of the function f with the function g is written as this, right? So this symbol, this is a f composed g, and is defined by this equation. F composed g of x is going to be f of g of x, right? So, if you were trying to learn this on your own, a lot of times when students see this symbol, they think it's multiplication. Then they try to multiply f times g, and that's not what it is, and it's just wrong, right? There's nothing you can do about it, and somebody has to tell you, hey, that's not multiplication, right? So this open circle in this form, this is called composition of function. This is read f composed g of x, and it just means f of g of x. It just means the second function inside the first function. So it says where the domain of f composed g consists of the values of x in the domain of g, for which g is in the domain of f, right? For that part of the domain, there's a 3-step process that I do to get it to work, right? And I'll showcase it once it pops up in an example. Let's keep it moving. Okay, so this is kind of like trying to explain where the domain of a composite function comes from. So say we have our domain, right? Just a set of input values. All right, just a set of x, some set of input values. Then the function g are going to take those input values and map them to some output, so some g of x, right? So we have some input values, we pass it through the function g, we get a set of outputs, right? So then we're going to take those outputs from g, so all the results we get from g, we're going to take those and pass those through the function f. And then we're going to get another output, right? So the domain of f of g of x is going to come from the domain of g, all right, from the original domain. There's like a little bit more to it. Again, for me, I feel like that's easier to see once we work an example or two. We're almost right at 10 minutes. Okay, we're about halfway. That's okay. So given this function f and this function g, we're asked to find each of the following. So the first one, let me see, do I have enough space? I think I do. I'm going to try to get it to fit. So f composed g of 1, right? So if we have, for part A, if we have f composed g of 1, again, what does this mean? This means f of g of 1, right? I'm being a little bit lazy. I think it's okay, right? So this is going to be f of, so let's see, g of 1. Let's go ahead and evaluate g of 1. G of 1 is going to be 1 plus 1. All right, usually we do it off to the side. I'm just, for the economy of space, I'm doing it this way. So then this is going to be f of 2, right? Because basically it's saying evaluate g of 1 first. When you do g of 1, you get 2. Then you take that 2 and then you plug it into f. So this is going to be 2 cubed, which is what? 8. Hopefully that made sense. Let's try another one. Let's try another one. Okay. Oops. Part B asks us to do g of f of 1, right? G compose f of 1. So basically reverse the order. All right. What does your intuition tell you as far like, you know, we have f compose g. Oh, yeah, f compose g versus g compose f. If we reverse the order, what does your intuition tell you? Should it be the same, or do you think it's going to be different? If you just had to guess using your intuition, right? You think you're going to get the same answer or a different answer? Let's see what happens, right? Let's see. So what does this mean? We have this g compose f of 1. This means g of f of 1, right? The second function inside the first function. So let's go ahead and evaluate f of 1. F of 1 is going to be what? 1 cubed. So then that's just going to be g of 1. And then if we plug 1 into g, that's going to be 1 plus 1, which is 2. All right, so we did not get the same thing. So what that means is that in composition of functions, the order is important. The order in which you do the composition affects the outcome. As with a lot of things in life, when you change the order, it affects the results. So there's a certain order for things to behave properly. Let's look at part C. Part C asks us to do f of negative 1. F compose f of negative 1. What does this mean? This means f of negative 1. The second function inside the first function. Okay, we're about to let you guys go. We still got a good amount of time. Almost. We have an official 10 minutes, but it's a little. I'm trying to keep you less than 10 minutes. But anyway, let's keep going. F of negative 1. That's going to be negative 1 cubed. So if we have 3 negatives, is the final result, if we have a negative times a negative times a negative, is the final result positive or negative? The final result there would be still negative, so it's going to be f of negative 1. But we know that result, I mean, we literally just did it, but I'll write it again. It's negative 1. Come on. Man, I am definitely getting old. Like, I feel like I cannot regulate my temperature. But again, it's usually like this because it's the morning. I'm kind of sitting in the sun. I got the blinds closed, but it feels like it's not doing anything. Anyway. And it's so weird. Like a thermostat is weird. Like if I set it to 75, it's like a little bit too hot. And if I set it to 74, it's like freezing. So it's kind of weird. Anyway, I think we got all of these. We got the 8, we got 2, we got negative 1. Okay. Let me see how many more. We got a good amount. I would like to just finish this. Let me do one more and then we'll check the time. So given this f and this g, okay, find each of the following, each composite function. Okay, so part A asks us to do f compose g of x. All right, this is going to be, this means f of g of x, the second function inside the first. Well, what's the second function? So this is going to be f of this x squared minus 3. So what we're going to do is replace each x with that x squared minus 3. This is going to be 2 times x plus 1. But again, we replace the x with the x squared minus 3. All right. Hopefully this is okay. I could write it different where it'll probably be more clear, but I feel like it's okay. So if we distribute the 2, we get 2x cubed minus 6 plus 1, and then we get 2x cubed minus 5. Okay. Style. Hopefully that's okay. Let's do part B. G compose f of x. So this means g of f of x, the second function inside the first. Well, what is the second function? In this case, the second function is f, which is 2x plus 1. So then we're going to get x squared minus 3, 2x plus 1. So because it's squared, we FOIL. If we FOIL, we'll get 4x squared plus 4x plus 1 minus 3. Ultimately, 4x squared plus 4x minus 2. Combine like terms, right? Okay. See the time. Let me do this last part. Let me see the time. We're still good. We got at least 5 minutes. C. F of x. F compose f of x. This means f of x. This means f of 2x plus 1. So we're going to say 2x plus 1, like this. That's going to give us 4x plus 2 plus 1. I'm going to run out of space. Let me do this real quick. I think it's just 4x plus 3. Okay, I'm gonna just put it with everything else. So I'm gonna shrink this down. Position this where it needed to be. We can put it like here, I guess. Copy, paste, and I'm gonna resize it. And I don't understand like why it's so exhausting. I don't know. It's weird. Let me see the time. We got time for another one. I think the chat is okay. We still got a little ways to go. Let's see. So we got, oh, and let's put that in a box. Let's copy and paste. Cool. Okay. So we got 2x cubed minus 5. You see it there. 4x squared plus 4x minus 2. And the last one, 4x plus 3. Okay. All right, so this more than likely will be the last one. Let me do this one, and then I'll let you officially go for the day. Let f be this and g be this. Find f compose g in its domain. Okay. So to find the domain of a composite function, there's a 3-step process that I recommend. The first step, so for the domain, the first thing is to find the domain of the inside function. All right. So in part A, the inside function, well, we'll get that in just a moment. But first, you want to find the domain of the inside function. Second, you want to find the domain of the simplified function. And then the third thing is to take their intersection. All right, where do they overlap? All right. So if we apply this concept, for instance, first let's find f compose g. So for part A, f compose g of x is f. It means f of g of x. All right. And so this means f of, what's our g of x is 1 over x. So this is going to be x plus 1. So that's 1 over x plus 1. Okay. So I'm just going to get rid of the parentheses because we can move this here. All right. And actually, I'm going to actually move that as well. Okay, let's go like this. I see the time. I'm watching the clock. Ooh. I have to make that work. All right. Okay. Okay. So f compose g of x. We get this thing on the far right. that we see here. I'm watching the clock. Okay. And then for the domain, so the domain of G, so for the first, I'm just call it A1 or the first part. The domain of G is basically everything except 0. So X can't be 0. And then let's go like this. And then the second part, the simplified function, again, I think it has the same restriction. The only restriction for the simplified part is that X cannot be 0. Right? So then the intersection, everything except X, intersection, everything except X is everything except X. It's the same set. A set intersects itself as itself, right? So then the domain here is going to be everything except 0. Let's try one more, and then that'll be it. Because I know that was a little bit, it's just weird, right? Especially the first time you're seeing it. Let's just try another one. Let me see the time. Yeah, let me just do this last one. Butler, I'm gonna let him in because he shouldn't be in there. Okay, so let's reverse the order. So for part B, if we're doing G compose F, this means G of f of x. What's f of x? X plus 1, so it's going to be G of x plus 1. So that's going to be 1 over x plus 1, right? About to let you guys go. Give me just a moment. So then the domain, so we'll say like for B1, the domain of the inside function is all rails. So I'm just going to put infinity. Or actually, let me use this symbol. This means all rails, right? So the domain of f is all rails. There's no restrictions on f. The domain of the simplified function, we want to get rid of, remember, we can't divide by 0, so x cannot be equal to -1. So for part B, for the domain of the simplified function, x cannot be equal to -1, because if we plug -1 into that simplified function, we're going to get a 0 in the denominator. So then for the third part, to take the intersection, all numbers, intersection, everything except 1, except -1, the result is everything except -1, right? If you consider the whole number line, and what does it have in common with the whole number line except -1? It's basically everything except -1, right? Give me just a moment. Let me see if there's any closing announcements I need to make. Let me compare this to what was in the prepared notes. And I'm going to keep going. I'm going to let you guys go. Give me just a moment. 1 over x plus 1. Yeah, 1 over x plus 1, and then everything except 0. Everything except 0. And then 1 over x plus 1, everything except -1. Cool, okay. So after this, I have about 9 more slides. Okay. So no real major announcements other than just as long as you're aware of exam 1, I do intend to make some scheduling for exam 2. It'll probably take me some time. I want to give each student about 15 to 20 minutes, something like that. I want the oral component of exam 2 to be 20% of your grade, right? So like if you just bomb it, you can still get an 80 or whatever, and I think that's fair. And for exam 2, that's going to be, what is this? This is what, September? Exam 2 should be towards the end of September. It's in week 8. So I think this is the start of week 5. So when we hit week 8, that's when we'll be starting exam 2. Okay. Nunez, is that from this class or a different class? I don't know. We're done here. Okay, guys, if you don't have any questions, I'm gonna just let the student in. I don't know if they're in a class or not. But if you don't have any questions, I'm gonna go ahead and finish this section out. But you're welcome to leave. You're not required to stay. Thank you for being awesome. Hope you had a great weekend. And I'll see you again on Wednesday. Okay. All right. So, like I was saying, I'm gonna go ahead and finish out this section. Let me see. Testing. Okay. So this is decomposition of a function or decomposing a function. So where before we took two functions and we put like the second function inside the first, so now we're going to work backwards. Given a result, can we break it apart into two functions and write it as a composition, right? So given this h, we want to write it as one function inside the other. So there's more than one correct way of going about this, right? There's generally more than one correct way. I'm just going to choose, I'll show two, right? So I'll do the first one in blue, right? So if we want f compose g, one possible inside function, the simple one, so I'm going to say let g of x be this 2x squared plus 1. That's one potential inside function. So if that's the inside function, then the outside function for that would have to be 1 over the square root of x, right? So then if we do f compose g of x, that's one way where we can get that 2x squared plus 1. We can get that result, right? Let's do another one. Let okay, now I'm going to let my inside function, let g of x, I mean, there's so many. There's a few of them. We can let g of x be x squared, right? So then f of x would be what? 2x plus 1 square root, you know, like this. So then that way when we do f compose g, we still get our desired result. Should be okay. I think I can do one more. Okay, let's do one more. So yeah, that's fine. I'm going to say let g of x in this case, I want to let it be 2x squared plus 1 under 1, right? I'm going to let it be this. And I'm going to let f of x be, I think, just the square root of x, right? So now when you say the second function inside the first and you simplify, just for the sake of space, I'm not going to show all the steps. I'm just going to kind of jump to the conclusion. It should work, right? So these are three. Let me see if I can see some more. I mean, these are just some of the ways, right? I'm sure we could find some, but you know, I'm gonna try to wrap this up. Okay, so let's see. So define g as an expression in the equation for h. So for theirs, they said let g be 2 of x plus 1. So then that made f of x 1 over root x. So that was like the way we did ours. Let's see. I don't think they did any others. Okay. So we have a couple of examples here, applications. So it says that oil is spilling from a tanker into the Pacific. I was totally about to say specific, and I knew it was wrong. I said to myself, "Don't say specific," and like, of course, I wanted to say specific. Oil is spilled from a tanker into the Pacific Ocean, and the area of the oil spill is a perfect circle. The radius of this oil slick increases at a rate of 2 miles an hour. Express the area of the oil slick as a function of time, and then calculate the area covered by the oil slick in 6 hours. So the area of the oil slick is a function of the radius, right? So area of a circle is pi r squared, right? And then it says that the radius is growing by 2 miles every hour. So the radius, or r of t, would be 2 times t. 2 miles times every hour, right? So the radius is going to be 2 times t. So the area as a function, as the composite function, we said f of g, but then g based on t, right? So here we said area as a function of the radius, right? But then we express the radius as a function of time. So then f of the radius, but then the radius you see right here is equal to g of t. So then you basically just do that second function inside the first, and then ultimately we get here. Okay, I know there's a little bit, you know. And then I think the second question says calculate the area covered by the oil slick in 6 hours. So after 6 hours, so now that we have our composite function of 4 pi t squared, so then after 6 hours, when you basically replace the t with the 6, you get 144 pi square miles. right? And you just put it in a calculator. It's like approximately a little bit more than 3 times that number, right? And you see it at the bottom, about 452 square miles. That's a lot. Jeez. Kind of makes me feel some way. Okay, I see the request in the chat. Let me wrap up this last one to kind of close this out, and then we'll come back and we're actually almost done. It always is like this. Like it seems like it's a lot more, and we actually finish it very quickly. A car dealer offers an 8% discount off the manufacturer's suggested retail price of X dollars for any new car on his lot. At the same time, the manufacturer offers a $4,000 rebate for each purchase of a car. Write a function R that represents the price after the rebate. Write a function D that represents the price after the dealer's discount. Write the functions R compose D and decompose R, and what do they represent? Calculate decompose R minus R compose D and interpret this expression. Okay. So R, it says it offers an 8% discount off the suggested retail price. So instead of paying 100%, you only pay 92%, right? Represents the price after the rebate. Okay. So then for that first part, I'm going to write this in purple just so it stands out. So the price after the rebate, again, if it's 8% off, instead of paying 100% of the full price, 100% minus 8% leaves us with 92%, right? So I'm going to write it like this, 0.92 times x. All right, so if x is the price of the car, then we should pay 92% of the original price. I wrote the percent as a decimal. I feel like this is okay. Write a function, let me see, D offers a $4,000 rebate for each person. Write a function D of x that represents the price of the car after the dealer's discount. Wait a minute, am I mixing these up? Price after rebate? Okay, I think when I wrote the D, I think this is actually D of x. So let me, I think that's why I was like, why does this feel weird? I think that's actually the second question, right? I think I just got the labels mixed up. And then the first one, let's go back to the first one. It represents the price after the rebate. It says the manufacturer offers a $4,000 rebate for the price of the car. Okay, and we'll do that one in blue, right? So then R of x, so the rebate, you have the price of the car minus $4,000, right? That's $4,000. Whatever the price is, you take out $4,000. But then the dealer's discount is an 8% discount, right? So if you only apply the dealer's discount, instead of paying 100%, you pay 92% because it's 8% off. So then write the functions R compose D and decompose R, and what do they represent? Okay, I'm kind of running out of space. I probably should give myself some space, but I'm not going to. I'm going to write this in orange. So then R compose D of x. So D inside of R, I'm just going to try to jump to the result. If we replace the x with that, so then we're going to get 0.92x minus 4,000, right? So that one is where if he applies the dealer discount first and then applies the rebate versus the other one, I'm just going to write it here. Decompose R, I'm kind of out of space. Decompose R of x. If we apply the rebate first, so that replaces this x, we're going to get 0.92 times this x minus 4,000. Right? So then you would distribute. If you simplify that, you'll get 0.92x minus whatever 92% of 4,000. Let me break up my calculator. Oh no, it's my battery. Calculator. Okay, I just want to do 0.92 times 4,000. 3680. All right, so you should notice something, right? So again, this is showing the order of applying these discounts. The first one, we applied the dealer's discount first, and then the rebate. And the second one, we applied the rebate first, and then the dealer's discount. And actually, this thing is real because I went in the store, and they had something like this. They had 2 different promos that you can take advantage of. But depending on the order in which it's applied, it affected how much of a discount. You get more of a discount with one over another, right? So in either case, it looks like you're paying like 92% of the original price, but in the first one they take off 4,000, but in the second technique they only take off less, which is the 3680, right? So if you want a larger discount, it seems like you should do the first one over the second one. The first one provides a larger discount than the second one. Am I doing that right? Let me see. That should be negative. Let me see. That minus this. No, it's positive. Maybe I got it backwards. Anyway, let's kind of look at the result. So the MSRP of the rebate is 4,000. So then X minus 4,000 represents the price of the car after the rebate. The dealer's discount is 8%. So 100% minus 8% is 92%. So you see it there. Okay. So then if you apply the dealer's discount first, you get, okay, did I get it backwards again? No, we're good. 92 minus 4,000, all right? Represents the price when the dealer's discount is applied first. This next one is the price when the manufacturer's rebate is applied first. You take off the 4,000 first, and then you apply the dealer's discount. Okay. So this equation shows that it'll cost $320 more for any car, regardless of its price, if you apply the rebate first and then the discount. Yeah, so what we said, that coincides with what we said, right? We would prefer the first one over the second one. We get more of a discount with the first one over the second one. If we do the second one first, we're gonna be coming out of pocket more, right? It's a little bit circular. Hopefully you can kind of see that. Another way you can see it is like, okay, suppose a car was $10,000, or you can do 20,000. If we did 10,000, right? If you plug in 10,000 into that first one, you know, you'll get one result, and it should be lower. Like when you plug it, I'm gonna just do it off to the side real quick just to confirm. I could put it up on the screen, but so for instance, if I say 0.92 times 10,000 minus 4,000, we will pay 5,200, right, for the first one. So if our logic is correct, then when we do it into the second one, it should be a higher number. It should be 55 something. So let's see. So if I say 0.92 times 10,000 minus 3680, right? We're paying more, 5520, right? So that's what this last part was saying. If we do the second technique, we'll be paying $320 more, just based on the order. Like that for stuff, because of stuff like this is why I fell in love with mathematics. It's hidden stuff like that. Like, and when you're not aware of that stuff, people take advantage of people. It's so bad. It's so bad. I mean, across the board. Like, I mean, honestly, as professors, that's kind of what capitalism is. It's like when you're aware of stuff like that, and you know that other people aren't aware, that's what capitalism is. Because everything that we pay for, it don't cost this much to make it. Like if you think about your phone, we pay these thousands of dollars or whatever it costs to get these phones. It don't cost that much to make it. You see what I'm saying? It's all sleight of hand. But it's because of stuff like that. That's why I study mathematics. So at least I can be aware. Because then when you're aware, then it's like, okay, you decide, okay, is this worth it? I mean, you know. And it just being aware of stuff actually makes a really big difference. Anyway, guys, if you're still hanging in there, you're a trooper. I appreciate you for being awesome. Keep up the good work. Let me check the chat real quick because I know that there was a request there. Mr. Baker, are you still here? Let me see. He's probably not here anymore. Yeah, he's gone. Okay, I wish he could have just typed this question there. So I at least could have answered it in the stream, but that's okay. Yeah. So the other thing is like, if with this presentation, if it's not familiar, what you have to do is go back to my recordings. So I'm a little bit ahead. This is a little bit ahead of where we officially are. Like I think the official, like if we just finished exam 1, which is 1.3, we really should have been starting 1.4 today, but I just went on and made those recordings, right? So you can always go back, watch it, take notes, bring your questions to class, right? So this would have been, we would have just been introducing 1.4. That's really where we are today. I just did the lecture for 1.6 just to kind of keep our rhythm. So for exam 2, we're going to be responsible for sections 1.4, 1.5, and 1.6. Those recordings are now currently available, right? Okay, guys. So on that note, we're going to end the stream here. We're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.